What's up, everyone? Welcome back. Moving on to another question with hypothesis testing. So a store wants to test whether a recent promotion has caused customers to spend more money on each visit. Before the promotion, customers spent $92 on each visit. After the promotion, a sample of customers is collected and their amount spent is shown below. So notice we have a list here. At a 5% significance level, is there evidence that the promotion worked? So notice that in questions before, we've been given the sample mean and the sample standard deviation. Sometimes we haven't been given the sample standard deviation if we were given the population standard deviation. But notice in this case, we're not given the actual parameters, we're given the actual sample data. So we're gonna have to find those parameters ourselves. So before we get into that, first thing I want to look for, like usual, is my population standard deviation known or unknown? And notice that nowhere in the question do they mention the population standard deviation. And so it is unknown. So we know we're going to be doing a t-test. We're going to be using the t distribution. Next thing I want to get is the null. Actually, let's write it here. The null and the alternative hypothesis. So notice that there's a promotion and the store wants to test whether the promotion has caused customers to spend more money on each visit. So notice that the store is looking in terms of one direction. So they're seeing right now customers are spending what, $92 on average on each visit. So the store wants to see whether they're spending more than 92 on each visit, whether that average goes up after the promotion. And so the null is less than or equal to 92, basically the opposite of that. So this here is a right-tailed test, right? So if we draw this in a diagram, I'll draw it over here. Basically, a right-tailed test means the rejection region, where we're going to reject that null hypothesis, is going to be right here. And this here, because we're doing it at a 5% significance level, this area here is 5%. So what we got to do is we got to figure out what's this critical value over here. And notice the critical value, it's going to be on a t distribution. And what's the degrees of freedom going to be for this t distribution? Well, remember, it's always the sample size minus 1. But notice we're not given the sample size, but we're given the sample data. So notice how many observations are made. 1, 2, 3, 4, 5, 6, 7, 8. Right? So our sample size is 8. So 8 minus 1. We know we're going to be working with a degrees of freedom of 7. And to get that critical value, I'm going to use the calculator. You could also look it up in the t table. So we go stat F5 for distribution, t distribution, and we're finding the inverse of t. We're finding a t-score. So data, you would input variable over here. This area, it's always the right-tailed area, so notice it's 5%, so this would be 0.05. Degrees of freedom is 7. And when you execute that, you would end up getting 1.895. So that critical value is 1.895. Right? So now what we got to do is we have to find our test statistics. So as before, basically, our t test statistic, it's equal to what? It's equal to the sample mean minus the population mean over the sample standard deviation over the square root of n. But as I mentioned, we're not given this sample mean and this sample standard deviation. We have to actually calculate it from this list. And so if you want to calculate the sample mean, you'd basically add all these numbers up, divided by 8. So when you add all of them up, you would get 775 divided by 8. you get 96.875. Right? So because we're dealing in dollars, you could have put 96.88, right, to get it to the nearest cent. I'm just going to keep it to 3 decimal places. Now, the sample standard deviation, it's actually more complex to calculate. It's going to take a lot of time to do it manually, so I'm not going to do it in this video. I did it in the video when we dealt with confidence intervals, when we found a confidence interval from a list where the sigma was unknown. So it's the exact same process like that. You could even throw it in Excel and do it. But if you do find the sample standard deviation, it would be 7.1. Right? So make sure if you do have to calculate it manually, usually you're going to be able to use a calculator, but if your prof wants you to calculate it manually, make sure you're getting that number. If you're not getting that number, let me know, and then I'll help you out in getting that number, whether through Excel or whatever. So sample mean 96.875, sample standard deviation 7.1, and now we could just plug it in. So we would have 96.875 minus the population mean, which is 92, over 7.1 divided by the square root of the sample size, which is 8. And when you do that calculation, you would end up getting 1.94. So that is our test statistic. And where does it fall on our graph here? Well, notice it falls right here. That's where 1.94 is. And so notice it's in the rejection region. So we got to reject the null hypothesis. So there's evidence that the alternative hypothesis is true, meaning that in this case, there is evidence that the promotion worked, that customers are spending more than $92 on each visit now. Right? So the conclusion is we reject null, and there's evidence that the promotion worked, or evidence that customers are spending more than $92 on each visit. And if you're to do this with the stats calculator, you would go through these steps here. So you'd go to the main menu, hit stat. Now, in this case, we got to input a list. You're going to see a column of different lists, so you could input it under list 1. You got to input these numbers here. And then you would go to F3 for tests, F2 for a t-test, and then we are testing one sample, and you would get to this input screen here. Now the data, usually it's variable, but in this case we are looking at a list. So you want to make sure that says list. This here is the alternative hypothesis. So notice it's greater than that population mean given 92. And the list, it basically specifies which list you want to look at. So you want to look at list 1, unless you input it into a different column. And when you execute that in the calculator, you would get this output over here. So notice that they give you the alternative hypothesis, they give you the test statistic, 1.94, which is what we got as well. They give you the p-value. Notice the p-value, how does it compare to the significance level of 0.05? Well, notice the p-value is less than the significance level. And so we know when that happens, we have to reject the null. So got the same conclusion. And then notice also from the list, they give you the sample mean, they give you the sample standard deviation as well, and the sample size. So that's pretty nice too. If you do want to use it, if you want to confirm this test statistic manually with that manual calculation we did. But yeah, multiple ways, whether you're looking at the test statistic, comparing it to that critical value that we got before on the t-distribution, or you're looking at the p-value, comparing it to the significance level of the test. Either way, the conclusion is that we're rejecting the null hypothesis, so there's evidence that the promotion worked, there's evidence that customers are spending more than $92.